Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 3.4, which is transforming quadratic functions. So pull up Desmos here. These are all going to be transformations from the parent function. And we've talked about these properties a little bit over the last few sections. Here, basically, all we want to do is to be able to describe how a quadratic is shifted, or if I'm given a function to say how it was shifted. Obviously, if we were using Desmos, we could just type it in and see that, but we kind of want to be able to do both. So here we're starting out with y equals x squared. That's your parent function. Remember, parent functions like the simplest function you can have in that family. So it's y equals x squared. If I want to move this graph up and down, I'm going to change the k value. So increasing k will move the graph up, and decreasing k will move it down. So some questions might ask you, back here on 0, some questions might ask you to describe a function that's been shifted from x squared to, let's say, x squared plus 5. If that was my question for you, you'd just say up 5. If I gave you y equals x squared minus 3, you would tell me down 3. So pretty straightforward there on that one. And that's true for any function family where if you change the value by a constant on the outside, then it's going to move it up or down respectively. So that's the k value. So k moves it up and down. Your h value is going to move it left and right. Now, the thing about the h that you have to be careful with is that up here, notice that my formula that we've talked about before, but the formula in vertex form is the opposite. It's x minus h. So if I, for instance, wrote y equals x minus 4 quantity squared, even though we're used to thinking of a minus as being to the left because of the number line, this is actually a positive 4. I'm subtracting a positive 4. So having a minus there is going to move it to the right, and putting a positive there is going to move it to the left. So just be careful with that. Students often get those two mixed up. So a minus will move it to the right, and a positive will move it to the left. So same thing, I could ask you to describe a function that has been shifted 5 units to the left, and you would tell me y equals x plus 5 quantity squared. Describe a function that's been shifted 1 space to the right, x minus 1 quantity squared. And then we could put those two things together. I could say, graph a quadratic, or describe a quadratic function that's been shifted 2 up and 3 to the right. So then you would tell me x minus 3 quantity squared plus, you're describing both. Okay. So that's h and k. That moves us up, down, left, and right. A value, if I put a negative here, it'll flip it. So some questions will ask about a reflection or a flip. So you just put a minus there. So when a is negative, it flips the graph upside down. A also, other than it being negative, will make my graph either wider or narrower. If I increase a, let's say changes from x squared to 2x squared or 3x squared, notice how it's getting compressed basically because it's increasing faster. So it looks like it's getting more narrow. And then vice versa, if I decrease a, but still keeping it positive there, then it'll make the graph wider. So a will make it wider or more narrow. If it's negative, it'll flip it. H moves my graph left and right. K moves my graph up and down. So describe a graph that has been made twice as wide, has shifted up 4 units and down 4 units. If I'm saying it's wider, that tells me it has to be a fraction. So instead of 2, it would be 1/2. And then what did I say? Left 4. If I want to move it left 4, then it's going to be +4 here. And then down 4. So just take it piece by piece. Hopefully this is a fairly straightforward lesson. You can add the sliders yourself directly if you want. Otherwise, this is also in your supplemental resources. But that's all for today, guys. Have a good day. Bye.